Alright, this is Destiny DK. Today I want to talk about carbon and its compound. Alright, carbon as it is, okay, is one of the most important elements in chemistry. Alright, and one of its unique properties is the fact that it exists, okay, in different forms but in the same physical state. That is, it exhibits allotropy. Okay, allotropy is a phenomenon which shows that an element can exist in different form but in the same physical state. Okay, carbon is one of the elements that exhibits this. Okay, you can find carbon in different forms. Okay, but in the same physical state. Physical state is solid state. So in this solid state, carbon can exist in different forms. You can see it in different forms. So why we say it exists in different forms is because of the fact that the forms that it exists in the solid state have different properties. Okay, for example, it can exist as diamond, it can exist as graphite, and it can exist as amorphous carbon. Okay, all right. Diamond is the strongest, is the hardest known substance. Okay, and it's octahedral in shape, transparent. Okay, but graphite is black. Okay, it's an opaque black solid. Do you understand? And it is hexagonal in shape. Okay, so you see that both of them contains carbon. Both of them are carbon. Basically, both of them are still carbon. All right, but because of the fact that both of them are in different forms. Okay, one is transparent, the other one is black. One is octahedral, the other one is hexagonal. Okay, so because of that, you can say, okay, these things are in different forms, all right, but in the same physical state. All right, so because of this, they are both carbon in solid state but in different forms. Most other elements do not possess that. Okay, most other elements exhibit as just one form. Okay, in the same physical state. Water exists as water in the liquid state. Okay, as steam in the gaseous state, and as ice in the solid state. There's no other form you can find water as in the solid state that is not ice. I hope you understand. So, but carbon exists in three different forms, but in the solid state. All right, as diamond, as graphite, and as an amorphous carbon in its solid state. Okay, so because of the fact that it exists in different forms that have different properties, different distinct properties. Okay, but in the same physical state. Do you understand? We say what it exhibits allotropy. So that's phenomenon that shows that an element can exist in different forms but in the same physical state. We call it what? Allotropy. I hope you understand. So talking about the allotropes of carbon, the allotropes of carbon are actually related in a way which I would explain much later. Alright. So we all know that what diamond is colorless. Okay, it's a transparent solid that is colorless and have a high refractive power. Okay, dispersion power. Okay, that's a high refractive index and dispersion power, which makes it very colorful. You understand, when light shines on it. Okay, so diamond is octahedral and it is the hardest known substance. It is the hardest known substance. As a result, only diamond can break diamond. All right, there is no other substance that is known to break diamond. All right. Okay, at least that is what we know about diamond. It is the hardest known substance. There is no other substance that is as hard as diamond. So as a result, only diamond can break diamond. I hope I am communicating. Do you understand? So aside that, it is highly resistant to high temperature and chemical attack. Am I communicating? It is highly resistant to high temperature and of course chemical attack. So you can understand that these are the properties of diamond. And diamond is a very bad conductor of electricity. It doesn't conduct electricity. That's because its molecule, the carbon in the diamond molecule, does not have any free valence electrons. Okay, so you know that carbon has 4 valence electrons. Four valence electrons. Okay, but in diamond, all the carbon atoms, all the carbon valence electron, that is all the valence electrons in the carbon atom, has been used for bond formation. Okay, they've been used to form bond with neighboring the carbon atoms. Do you understand? So because of that, there is no free electrons. Like the 4 valence electrons have been used for bond formation, so there's no electron that is available to conduct electricity, for the conduction of electricity. Okay, any substance that conducts electricity has mobile ions or mobile electrons, because current itself is the movement of charged bodies in a particular direction. So if these charged bodies are not available to be given energy enough to move, they cannot conduct electricity. So because of that, that object that has those ions cannot conduct electricity. So for a substance to conduct electricity, it must have free valence electrons or free mobile ions. Okay, you understand? So diamond does not have any of this. Okay, the only thing that can make diamond conduct electricity is the valence electrons that are in the carbon atoms in diamond. But since all of them, they've all been used to form bonds with neighboring carbon atoms in a diamond. All right, that means there's no electrons, there's no charge available for conduction of electric current. So that's why diamond is a very bad conductor of electric current. Do you understand? So these properties that I just mentioned now about diamond, they are what makes diamond special, and that's what makes diamond to be useful in the industry. For example, due to the hardness of diamond, all right, only diamond can break diamond. So because of that, diamond is used to cut glass. Diamond is used for cutting glass. Diamond is used because of its hardness again. Diamond is used as a precision instrument. Okay, as a precision instrument. It's used in pivots as a precision instrument. So it is used in drills for mining. All right. Okay, that tool that is used to drill hole into the ground. Do you get it? Into hard rocks. Okay, when they discover that a mineral is in a particular earth crust or under a particular rock, so they use hard drills to drill hole into the place where the chemicals is located, and that is how they get the chemicals. So you observe that diamond is one of the substances that is used, one of the many materials that is used because of its hardness. Okay, you can drill into hard rocks, okay, into the mineral bed where it can be extracted. Do you understand it now? All right. So because of diamond's hardness, it is used also to sharpen as an abrasive for sharpening very hard tools. It can be used as an abrasive for sharpening very hard tools. Okay, you want to sharpen tools in industries that are used for large multipurpose applications. To use diamond to sharpen it because of its hardness. All right, and also because of the high refractive index and dispersion power of diamond. Okay, it gives it a sparkling brilliance whenever light is shined on it. Okay, which makes it useful as jewelry. Okay, you understand? So that's just thinking about diamond. All right, for graphite on its own, graphite exists as an opaque black solid. Okay, yes, and graphite exists as an opaque black solid called plumbago. All right, this opaque black solid is hexagonal in shape, and it exists in layered crystalline structure. Do you understand? So each layer consists of like an hexagon, okay, whose vertices are made of carbon. Okay, do you understand? So in each layer, one vertex is carbon, the 6 vertices. So each vertices contains carbon. Are you getting it? Carbon in each vertex. Do you get it? So the carbons are bonded to each other in each layer. Okay, then each layer is then bonded to the next layer below and above it. When we say it exists as a layered crystalline structure, that is, each layer which is an hexagon. Are you getting it? Do you get it? Each layer which is an hexagon are arranged on top each other. So one layer is bonded to the next layer and the next layer and the next layer. That is how it is. Okay, so each layer, the layers are held together by weak van der Waals forces. Do you understand? But the carbon in each layer, okay, the carbon is bonded to the next carbon in each layer. Like I said, the carbon in each layer are positioned in the vertices of the hexagon. So the carbon are bonded to each other in each layer by strong covalent bonds. but the carbon, the layers are arranged on top of each other, and one layer is bonded to the next layer by weak van der Waals forces. Because of the fact that these van der Waals forces are very weak, that makes the layers to be able to slide above each other. Do you understand? Apart from this, a graphite is a very good conductor of heat. Is a very good conductor of heat. If you look at the structure of an hexagon, you find out that one carbon is bonded to two or three other carbons. Do you understand? So if you consider that, you find out that at the end, the valence electrons in each carbon, okay, out of the 4 valence electrons, only 3 are used for bond formation. Okay, so the remaining 1 is free to move, and that makes graphite a very good conductor of electricity. You see why we said that diamond and graphite are both allotropes of carbon, because they're in different forms. In one part we say carbon is diamond is very hard, and of course diamond is a bad conductor of electricity. But now we are saying that graphite is black and is a good conductor of electricity. So that tells you that diamond and graphite are 2 different substances, but then they contain carbon. So they are basically carbon. They contain carbon majorly. Do you understand? That's why we say they are both allotropes of carbon, because they are carbon in different forms. Do you understand? So they exist in different forms, but in the same physical state. So in graphite, for example, in graphite, as we have been discussing, graphite is a very good conductor of it because of its the presence of its mobile electrons. Are you getting it? And that is that about that. Okay, apart from that, okay, diamond flakes easily. Okay, you understand? It flakes easily. Do you understand? So due to these properties, we can use graphite for so many things. Number one, because of this good conduction, it can be used to make another substance that is not a good conductor of electricity to be conductive. Okay, a non-conductor of electricity or an insulator, you want to make it to conduct electricity, you can coat it with graphite. This makes it possible for us for it to be able to conduct electricity, because graphite itself can conduct electricity. It's a very good conductor of electricity, of heat and electricity. I don't know if I'm making sense. All right. So another thing about graphite is that because of its layered crystalline structure, the layers can slide over each other. This makes it very useful as a dry lubricant. Okay, it can be used as a dry lubricant, that is to prevent friction between 2 rubbing surfaces, because it's dry, and it is a better lubricant than the major lubricants that you have, like grease, engine oil, and all that, because unlike the grease and whatever, you'll find out that graphite is dry and it's non-sticky and it's not volatile, while all those other ones, they are volatile, they can vaporize easily. But graphite, being a solid in solid form, is a dry lubricant. It is non-sticky and it is non-volatile. It doesn't evaporate easily, and that makes it last longer. Do you understand? In fact, as a matter of fact, sometimes they mix graphite with grease, okay, to produce a high level lubricant. Do you understand? So that is one thing about graphite. Graphite is also used as an electrode in electrolysis because of its good conductor of electricity. An electrode is used to transfer electric currents in and out of the electrolytes. Do you understand? So we need a very good conductor of electricity, and that's why we use graphite. You understand? So, and another thing about graphite is that graphite is mixed with lead. It's mixed with lead to produce lead pencil. No, graphite is mixed with clay, to produce lead pencil. The lead pencil you use all around, okay, is produced by mixing graphite with clay, the black clay. Okay, that is what manufactures that that is how they manufacture the lead pencil. Do you understand? So all these are properties of graphite. Do you understand? And that is that about that. Okay. Then we have amorphous carbon. Okay, amorphous carbon is just some particles of amorphous carbon is just some particles of graphite that are held together, by impurities. Do you get it? So that's what we call amorphous carbon. All right. Examples of amorphous carbon are coal, coke. We have coal, we have coke, we have coal tar, coal gas, we have charcoal, All these substances are what are examples of what of amorphous carbon. So in my next video, I'm going to explain more about amorphous carbon, and I'm going to tell you the relationship between this amorphous carbon and the relationship they have with what? With graphite and diamond. Most people don't understand. Most people don't know that this diamond and graphite, diamond is gotten from carbonaceous materials like bones, flesh, bones, and trees. These are the starting materials of what? Of the diamond you see that is shiny. Everything is coined, everything is gotten from the bones of animals that dies, and they go into what? Into water bodies, okay, and settle in the water, in the seabed. Yes, most of them. All right, and even trees, remains of plants and animals, all of them, when they enter into water bodies and settle in the water, in the bottom of the sea or the bottom of the ocean, all right, something happens to them, and that's how they little by little they get converted to what? To other allotropes of carbon before the final product is what? Is diamond. And I'll tell you that in my next video. Thank you very much. If you are not subscribed, please do so that you can get consistent classes like this.